Okay, so I think we'll get started now. So I'd like to welcome everyone to this virtual conference on advances in 5G evolution and cybersecurity. In this virtual conference, Dr. David Soldani will talk about the 5G evolution from 3GPP-R release 15, enhanced mobile broadband eMBB, to the 3GPP release 16, industrial IoT, and 3GPP release 17, as well as consumer IoT. So he's going to cover a lot of important topics related to advances in 5G evolution and cybersecurity. Just a little bit of introduction about David. So Dr. David Soldani is with Huawei Technology. He received a Master of Science degree in engineering with full marks and magna cum laude from the University of Florence in Italy in 1994, and a Doctor of Science degree in technology with distinction from Helsinki University of Technology in Finland in 2006. In 2014, 2016, and 2018, he was appointed the visiting professor, industry professor, and adjunct professor at the University of Surrey, UK, University of Technology, Sydney, as well as the University of New South Wales, respectively. Dr. David Soldani is currently at Huawei Technology, serving as Chief Technology and Cybersecurity Office CTSO in Australia, as well as an ICT expert within the Asia Pacific region. Prior to that, he was the head of 5G technology E2E Global at Nokia and head of Central Research Institute, CRI, and VP Strategic and Innovation in Europe at Huawei European Research Center. So we have a very distinguished presenter today, and please welcome him, and he'll give his talk next.
So thank you so much for the kind introduction and for hosting me today. And yeah, my experience is of more than 25 years in the information communication technology, and I have been serving the most at Nokia and Huawei Technology, but I've always contributed as an academic. I'm still involved and active at university, in this particular case at NSW, and thanks so much the UTS for the discussion we are having today. I have organized this presentation. It's about 50 pages into 4 parts. So we go first through about the 5G, so there is a lot of confusion, and I hope I have a chance to clarify the main aspect of architecture and supported technology use cases. Then we talk about the 5G in terms of security requirements. So there are very important requirements the industry and in general has to support. And then I will go through the 5G security standards, so what we are receiving as functionality and requirements for standards. But the most important part is the last one, where I will show examples of security deployment. Starting from 5G and its evolution. So as we speak, we have 81 commercial 5G networks already deployed in more than 40 countries. And Australia, for example, has already a commercial launch with Optocenters trying yesterday ahead for VJ and TPG. So basically TPG now that we launch a few hundred 5G sites by the end of this year. So as we speak, 5G is on and gear up Namely, we have already commercial networks pretty much all around the world supporting mobility as well as fixed wireless access. So FWA stands for fixed wireless access. In particular, we have registered a massive deployment of the 5G system in China, accelerated by the coronavirus pandemic, as well as by the anticipated launch and assignment of spectrum. And there are already more than 250,000 nodes deployed, connecting more than 60 million. So you need to give you just a rough number to understand what we're talking about here. We have, let's take an example, UK and Australia. So Australia, around 10,000 sites in the C-band would be sufficient to have satisfactory services and coverage all over the country, and 25,000 would serve UK nicely. And here we are already talking about 250,000 with expectation of achieving up to even more than 600,000 base stations by the end of this year, bringing connectivity to more than 180 million terminals. And so the pandemic has also stimulated and incentivized massive development of new applications. So it's not just speaking about the cellular phone, but we have more than, as we speak, 600 type of service application in the field of, okay, we have industry application, transport, medical treatments, as I said before. We have many applications for stemming the coronavirus pandemic, but we are also seeing a massive development deployment of industrial application, especially it is about the industrial internet. And the other question is at which frequency the system radiates. So the most important enabler to have an economy of scale and adoption and development and rollout of the 5G system, it is the spectrum availability. And as of today, we have the system mostly deployed in the band 77 and 78, which is the broad overlapping of this C-band. So we're talking about around 3.5 gigahertz, and even considering the upper band, we talk about 4 gigahertz. We are also having deployments in the millimeter wave, and here you may see the adoption in terms of licensed deployed network, as well as investment in the phase of evaluation. And we're already talking about more than 173 operators investing in the system, and those are the bands mostly utilized for 5G services. As I said, the most in use is the C-band, so around 3 gigahertz, but we also have a massive deployment in millimeter wave. Here you have the ranges. And we are also having utilization of spectrum below 3 gigahertz. In particular, we do have the TDD deployment at 2.6 gigahertz, and then the 700 megahertz that allows not much speed because the band is pretty limited, but massive connectivity and coverage at 700 megahertz. Then the other question is, yes, if that is the system, the network, what, you know, more than 100 carriers are deploying, the question is, do we have the devices? Do we have an ecosystem? So can we really use these services? The answer is definitely yes. So I've just extracted today the latest report from GSA. You may find behind this link. And what we have is that we are already have 16 announced form factors. So the device is not just about smartphones, but we have the possibility of using 5G on laptops, notebooks, model, CP, like fixed wireless access, routers, gateways, TV, etc. And we have more than 86 vendors who have already announced the availability of the 5G devices. And you may see from those two figures below is the supported spectrum that we have already discussed, and above is the pie chart that presents the how those particular devices are distributed. So we have, of course, predominantly is the availability of smartphones, then followed by the CPEs for the fixed wireless access, and then we have a number of different models, because 5G has been designed for bringing services not only to the smartphones, but to anything and everything. So what we have today is that the system is ready, the ecosystem is ready, spectrum is ready, and 5G is a service already in place. And now I would like to present how the system has been conceived, designed, deployed, but more importantly, how will that evolve so that all the three usage scenarios, which is enhanced mobile broadband, ultra reliable latency communication services, and the massive machine type of communications can be supported. And I'd like to start from the architecture, because there is a lot of confusion, and I think not too many people still that haven't clear what the 5G is. Somebody think of a general distributed system with no starting, no ending, whereas the system is crystal clear design and copy and paste the architecture already in place for many years, coming from the GSM to G, 3G, 4G, and now we have 5G. So we do have the same type of network design in terms of network domain. We do have a radio access network followed by a core network, and then an independent evolving transport network layer that connects the two network domain. Now, going a little bit more in detail, we talk about two main system configuration. This so-called non-standalone configuration, which is basically a 4G system that you can see here. So you have the access network, the long-term evolution of eMBB, so the radio access 4G connected to an evolved packet core, which consists of equipment that take care of the mobility, access of terminal, and then gateway. So that's the core. And the first configuration, denoted as non-standalone, or if you want, option 3 in the different flavors or family, consists of a 4G network end-to-end with an addition of a new radio station, which usually it is co-located with the other baseband unit that radiates at 4G, and typically the implementation is to have one box that is multimodal, so that supports any kind of access technology. Very simple. So the first deployment comes with your option 1 configuration. That's a 4G system that adds a new radio station, which provides an additional pipe or data, the so-called dual connectivity to the mobile phone that will receive data and signaling through the LTE station. And then in the so-called secondary better split, so the split communication receives data through a new radio station, and in addition from the LTE base station. It's just pretty much a software upgrade, depending on the status of the hardware of the operator. And here we are. We have your new radio station that radiates and boosts the speed in your mobile phone. That's the first configuration in place. The other configuration we talk about is it's standalone. Standalone means it's a fresh end-to-end new system, and typically consists of a new radio station and the introduction of a 5G core. Now, like earlier, you see here there's a clear interface that separates the radio access independent of the protocol you're using to communicate through the radio interface and the core network. In its standalone configuration, the interface remains. Actually, it's even more standardized and open because it's also unified. So the first time in history that we assist at a one interface to any kind of access and connecting terminals. So that means that the 5G core will allow us to handle any type of communication independent of the access, whether the access it is 3GPP standardized, like an evolved LTE or a new radio, or it could be even Wi-Fi through an interworking function. And the standalone has been standardized already in release 15. So we have the possibility of going forward a carrier with the deployment on your system, attached to your system or node and your existing core network, which is pretty much a software upgrade of your box. Or we may think of overlaying your system by deploying an adjacent core, which then is connected through a standardized unified interface to either a new radio station or an evolved LTE station, which supports exactly the same type of interface to the core network, 5G core. Usually, the deployment, it is multi-vendor, which means a carrier for many reasons. One is the security and introduction of redundancy for achieving network resilience as to the vendor. So they tend to have a one vendor that may provide a core network and a part of the access, or other vendor that may provide only the access. How the system evolves and will evolve. So if it is clear now how the 5G system looks like, not only in terms of standard, but also how the equipment are designed, developed, and deployed in a multi-vendor scenario, we now try to understand how the system will evolve. And finally, ultimately, we have that all the configuration will converge to the option 2 in its standalone, which is about the 5G core connected to all new radio stations. So that means an interface also of next generation. How we get there? So if the operator of any kind, starting from the option one, so the 4G system decided to move forward in a non-standalone configuration, just attaching the new radio station to his existing system, we then had to include in the system and make them coexist an option 3 that will smoothly refarm towards an option 2. So we will assist in 2 steps the LTE refarming, which is not just about refarming the spectrum to the new radio that supports all, but it's also about retiring the 4G equipment. The other part is, okay, look, I am keeping my system as it is, and I'm overlaying that step by step, also considering how I'm going to use the spectrum, radiating, and different use cases, a fresh 5G system parallel to that, so that I may have an inter-system handover between the 2 communication systems like it works today between, for example, the 4G system and the earlier generations. In this case, the only communication we are having between the two system is via the core network. And finally, refarming the LTE, including spectrum, migrating step by step all the devices, and achieving an option 2, which is the 5G system in its standalone configuration, where both the radio access network and the 5G and the core are of next generation. Okay, so that's in high level how the system has been designed, conceived, and will evolve. And now I would like to present what the standard has planned to come next. And so we have started talking about 5G from release 15 onwards, and that was already completely finalized in 2018 in and supported both configurations. So the one I presented earlier in non-standalone and standalone. Now the system will evolve. So we're talking about 5G phase 2 and then later phase 3. 5G phase 2 is associated with the 3GPP release 16. And here you may see the timeline. And as we speak, the phase 2, so release 16 has been finalized. So it's been right now. Right now we have the system completely specified. So we are expecting 6 months or more from now, having access to the new features and supported functionality. Then will be followed by the release 17. Release 17, the content of which has been already agreed in December last year or beginning of this year. And the study items completed as well. So we're expecting then the future announcements being finalized next year, and then the new system and feature will be ready in the market as well. Now, I'd like to present what is new, what is coming in release 16 and then 17. I mean, there are many, many, many functionalities. So I've just taken a few that were also presented recently by the 3GPP delegates, and you may find the supporting documentation just behind the links I have embedded in this presentation. Now, looking at the release 16, this release has been conceived for, or sets the foundation for the industrial IoT. And in practice, it does support, actually enhances ultra reliable low latency communication services, because most of them are already supported by the release 15, like a packet duplication or the short time slot to transmit and so forth. But with the release 16, we have further announcements. It does support licensed share and unlicensed spectrum. This is very, 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 very important. It supports private networks, time-sensitive networking as an application function. Only the release 17 then will be native time-sensitive communication. So for the release 16, we just have a way to support the functionality in terms of seeing as an application function to the 5G system. Supports positioning, and in particular, I would like to stress the fact that the cellular vehicle 2X, practically they are coming with the 3GPP release 16 with the new radio. Although, as I present now, next, something is already supported in 4G. And the system enhances up to 6 nines the reliability, and in particular provides better MIMO, multiple access, multiple input, multiple output system, a sort of like of coordinated multi-point transmission. And in addition to those functionalities that are working items, so completed, as we speak. And the working group have produced actually 25 technical report or study item completed that will pave the way towards the working item in the release 17. And here you have a list of the studies completed, and we are talking about non-terrestrial type of network, so where the satellites are not only considered as a backhauling system, but it will be a real access system that complements the cellular technology. In addition to this, we will have the support of multimedia transmission and local area networks, wireless and wireline convergence will be fully supported coming release 17, and then enhancement to positioning and location that basically are introducing what is supported by the next release, that is release 17. And release 17, it is an important enhancement of the 5G system because it wider the supported ecosystem massively. So the target is in high level to move from release 15 supporting and enhancing mobile broadband communications to release 16 to cope with more ultra reliable low latency communication services, and then think of further enhance the system release 17 with bringing connectivity to massive type of communication. And that's why the release 17 will allow us to support spectrum up to 71 gigahertz. So earlier was limited to 52.6 gigahertz. It will also allow us to connect to massive machine type of communication, in particular the wearables, industrial sensor, and enhanced massive IoT. It will support extended realities, virtual reality, augmented reality, mixing the two of them, which are much more improved and user experience. And if you look at the enhancement targeting the industrial IoT, but I would say especially the consumer IoT, in terms of whatever wearable devices, or it could be like a healthcare monitoring function, or even industrial cameras or cameras for surveillance. The 3GPP release 16 comes with new radio light interface. So it is a fresh new protocol to allow those particular communication to access the network in a ultra reliable and improved connectivity and communication. So the NR light, it is basically represented on this spider diagram, where we have tried to map all the communication services starting from narrowband IoT, eMTC included, in other words, low power wide area IoT devices, or LPWA as said, which are already being finalized, which were finalized already in release 14 back in 2017, and those particular narrowband communication are kept evolving. So they keep evolving even in later releases. But in parallel to that, we have then introduced the enhanced mobile broadband communication services, and here you may see the requirements met by the particular protocols in terms of peak data rate, reliability, latency, battery life, cost, and coverage. Then URLC coming, especially enhanced in release 16, as illustrated in the roadmap below. And then in release 17, we are talking about NR Lite, which is a technology that it's not good, extremely good at anything in particular, but it does resolve pretty much all problems. So that's why it targets with the way to connect millions of devices per square kilometers. And here you may see the relative performance compared to the earlier features. Exciting. Now, let us see some of the application coming with release 16 and then further enhanced in release 17. I'm talking about the cellular vehicle 2X. And as we know, this feature was introduced and supported by the 4G. The case of LTE with the introduction of side link. Side link means, okay, let's look at this system here. You have the radio access network, in particular one base station position here. These are antennas, and then you have different type of devices. Namely, in this case, you have two different devices. You do have a car and a roadside unit, which the system treats the same. Then they have introduced a link, a side, I mean, it's denoted side link because you have uplink from the car to the net, to downlink from the net to the car. So how do we call it? Okay, I go outside, side link, it is the link between devices. And the PC5 is this interface between devices. So look at LTE. Yeah, so the 4G system already supports the side link, but the application services are especially in the, I mean, in the direction of broadcasting, so public safety. Whereas with the 3GPP release 16 and the new radio introduction in complementing the LTE technology, so there are various configurations, but it doesn't matter. We are capable of supporting through the side link, like presented here, not only broadcasting the basic safety messages, but we are talking a real communication between vehicle to vehicle, vehicle to pedestrian, and vehicle to the roadside unit. And the scheduling of this particular interface, so between, I mean, the side link, how is that done between the devices? It can be either handled by the network in the case we have coverage, or in the case of out of coverage has to be pre-provisioned, and it is done autonomously by the terminal in a contention-based manner. Now, that's basically what we will have in release 16. So maybe massive deployment starting end of this year, beginning of the next year, and then release 17 will further enhance the side link, as well as will introduce the proximity services for critical communications and public safety applications. So we are ready then to have any kind of possible scenarios between devices where the network may or may not be there. If it is there, we'll assist into the communication between the peer entities. Just two words, because it is very, very important to understand how the railway system will evolve. Even here, not everybody is aligned in this direction. So I'm talking about the evolution of the GSMR and the industry, in particular, the International Union of Railways, UIC, and has been broadly agreed that the GSMR will retire by 2030. So you may consider how many kilometers of infrastructure we retire. Yeah, to know more about this, you just click on this link. And you may see the vision that UIC has made available. It's already more than 1.5 years ago. And what they did also, they output a very comprehensive specification, so requirement specification, which is behind this link, which consolidates requirements for 3 types of service categories: performance, business, and critical application, which are essential for the train movements and safety or legal obligation. We're talking about emergency shunting presence, tracking maintenance, etc. So what is the future railway mobile communication system? And this has been already agreed. That will be 5G release 16 and 17. And these requirements have been already incorporated into GBB technical specification, and it is already available as the specification on the mission critical push to talk services, but also the other important mission critical applications such as video, data, and critical services as well. And that will come in release 16 and further enhanced in 5G release 17. So it's very clear, huh? It's a huge investment now, because we have about less than 10 years time frame to migrate all this amount of infrastructure GSM. So it's basically it's a 2G jumping from a GSMR system to a 5G system, release 16 and 17. Yeah. And that's for the railway communication of any kind. So that was the first part. I will now jump into the security part and then some example applications. 5G requirements in terms of security. We do have in the industry four main type of requirements. And the carrier focus is especially placed on the multi-access edge computing, as we show you. So security around the deployment of the MAC, but there are also some concerns on network slicing. So you may imagine that your physical infrastructure now accessed not only by a number of devices, terminals, machine of any kind, but there will be also multi-tenant interface that other operators or vertical segments will have access to a network. So there are many concerns. Then the other concern is the massive connectivity. So the massive and the amount of connection to be established and creating load towards the control plane, user plane. And then the security management. So we need to have a very easy way to go forward towards risk mitigation, transparency, and compliances to laws and regulation that has to be automated as much as possible. And then other requirements are coming from the fact that the system is expected to connect something well beyond mobile phone. So if I am breaking into a mobile phone, the consequences could be a minor concern compared if I am, for example, orchestrating a car, yeah, or entering into the merit of a logistic process and so forth. So there are more stringent requirements coming from the vertical sector that we need to support. And I will show you in particular what it means when we deploy the MAC for reducing latency between peers. The other type of requirement, extremely important and a must now for the vendor to comply. It is the possibility of having in place well-trusted security assurance scheme. And we are currently talking about two frameworks. We do have the common criteria, which is a well-established way of achieving certificates of compliance to certain level of assurance. And then now coming, importantly, the common criteria, especially valid for the information technology. So it's in the IT special sector and not really suitable for the, although there has to be in place, but not really comprehensively designed for the telco sector. Now, for the telco sector, we are talking about this NESAS, SCAS method, with the contribution from two organizations, GSMA and 2GPP. And I will present this scheme because it is extremely important and of demand by the carrier. So the vendor need to meet those particular requirements. Right. If we now look at those are in general, say in high level, the main requirements coming from various stakeholders to the 5G system. Now the question is, how do we meet those requirements? And I will show you two things: how the standards comes forward with new mechanisms with respect to the 4G. To ensure trustworthy product and resilient networks. And then more importantly, I will show you what it means in terms of security deployment, which is the most important thing. Now, let us look at the 5G system in release 15. Release 15, coming with a new radio to configuration presented you earlier, introduces already a robust and an excellent security posture compared to the 4G system. I have some functionality I will present to you in the next slide. But at the same time, it also introduces security assurance schemes. And this is particularly true for the 4G enhancement as well as the 2GPP network element evaluation. Then release 16 and 17, they are further enhancing those security characteristics and aspects of the system in terms of assurance. So there are new scheme coming applicable to other function, especially of the core network, in addition to the one already mandated for the release 15, such as assurance scheme for the new data analytics function, the interworking function, when we talk about connecting to the 5G system through our Wi-Fi or non-3GPP trusted type of access. Then we have service communication proxies security assurance scheme and other functionality to be supported. In addition to this, we have many important enhancements in terms of security architecture and security enablers for the vertical industry, such as new security scheme for the verticals and 5G LAN supported network slicing. I will present you in detail. Consumer type of IoT communication. And then we have already schemes in place for authentication and key management for application on top of the 5G system. So the thinking is of connectivity to something well beyond a smartphone. So it's the Internet of Things. Okay, then there are other functionalities equally important, including how we need to handle the deployment of the mobile edge computing platform, as I will show you later. All those details summarized in a very high level on this slide can be found beyond this link, and all the technical specifications, say the 33 series .xyzr technical specifications for 5G security and security assurance. So the X, if X is 5, those are the technical specifications for 5G, and the rest you may guess what they are. Yeah, looking at the quick comparison of what is supported by the 4G system compared to what comes already in release 16 and 15, sorry. For the 5G, we have that, in short, the key for the encryption will be double at a later time, but more importantly, what we have that the 5G supports integrity protection at radio interface, which was not possible before release 15. We do have also support of privacy, because the international mobile subscriber identity is concealed, so is encrypted since the very beginning during the registration, so the establishment, the communication from the terminal. So we have privacy in place, which was not the earlier. Then in addition to this, we have the possibility of setting policy well beyond the network level, so we could really discriminate how we want to have the security deployed and the corresponding policy at the better level, slicing level at the communication level, because with the 5G we are able to discriminate down to the single packet. So the 5 tuplet, which are the flows of the packets traversing our network. Then in addition to this, we have the 5G introduces a unified way of authenticating the access to the network that is independent of the type of access. As I mentioned earlier, it's the first time in history that we will have a 5G core network that will allow us a unified authentication independent of the type of access. That could be like a 4G access, 5G access, or a Wi-Fi through an interworking function, meaning that we have now a unique way, a unified way, a global way of identifying both the subscription and the terminal equipment, and therefore providing the corresponding peers access and encryption as security. In addition to this, we have the introduction of encryption between the network domains, so that even in the roaming case, when the traffic crosses a visiting and a homing network, the data is practically encrypted. So that's just to give you a view of how many more things are coming in the first deployment of 5G in its standalone configuration when you deploy a 5G core. So the 5G core is more secure than running your traffic through an evolved packet core where there is no enhancement in terms of security. You see many contradictions, people talking about many things. So the real robustness and posture of the 5G communications in all terms, encryption, key management, authentication, and security deployment, it is further enforced through the introduction of the 5G core. Now, I would like to answer to the question is, yes, but how do we ensure and we provide the security assurance? And I would like to cover a little bit in detail what the GSMA together to GBP are doing in terms of achieving ultimately having an organization that will use those schemes for providing a certificate. So use those reports coming out through this particular process to then achieve via an accredited organization, a certified authority, a certificate. So I'm talking about the NESAS and 3GPP SCAS. What is it in practice? So what we're talking about here, it is an industry-defined and voluntary scheme that the vendors, through which they are basically evaluating their products in terms of development life cycle, and at the same time they do evaluate the network equipment supported functionality in terms of security. The functionality I presented to you earlier, example of what is evaluated through the equipment evaluation. And practically, the NESAS stands for Network Equipment Security Assurance Scheme. It is defined by the two most important organization, industry organization in the mobile communication industry, so GSMA, that is the association of the carrier, and the 3GPP, you know that they are assembling the most important standardization body. They are responsible for the definition, the technical specification, which are then transposed by the corresponding SDO, so the standardization body, like ETSI, or I was, for example, I am still in Singapore supporting the government, the eMBB transposes those particular specifications into standards. So these two organizations together, they are now providing an industry-wide security assurance framework that facilitates and improves the security level across the whole mobile industry. So that's basically an action that meets the requirements. The third category of requirements are presented early, and in practice, the NESAS consists of two main schemes. We have the security requirements as assessment for achieving secure product development, actually for evaluating, auditing that the vendor has a secure product development and product lifecycle process. So let me look at how you make the products and how you handle the life cycle, how you manage your life cycle, your product. That's the first question. Let me have a look at that. Yeah. The second, once I have audited how you make those products and how you maintain across the whole life cycle all those the process you're having, I want to have a look at your network equipment. I hope it's clear this. Yeah. First, let me see how you do things, and then I will want to see into what you have done. Yeah. And the what is means they are defining the security evaluation schemes for the network equipment, and the evaluation is based on the 3GPP standard. Yeah, nothing else. So as we speak, they are already available, and the specification for the process, we are talking about the NESAS 1.0, and that was already approved, finalized, and frozen last year in October. And this is already ongoing. So we have Nokia going through this process, Ericsson, Huawei. I will show you about our organization, what they've done. And let us understand what is it a little bit in detail, and the corresponding responsibility between the two organizations. So look at this slide, and in particular this house here. You have the fundamentals are here below, and then you have the upper part. The upper part, it is within the scope of GSMA. So they are responsible of producing the network equipment security assurance schemes. So we do have an overview out of which I've extracted this presentation. But also they have finalized 3 type of specifications. The one dealing with the security test laboratory accreditation, the requirements, the process. Then we have the vendor development and product lifecycle assessment methodology. And the last part is about the vendor development and product lifecycle security requirements. So that's within the scope of the GSMA, that GSMA basically defines and maintains this NESAS specification, and it is also responsible of the dispute resolution if anything happen. And you may see here how the organization it is positioned in terms of governance and the scope of the specification. So that's within the responsibility of the GSMA. And then 3GPP complements that by providing the technical specification for a security assurance requirement and assurance methodology for the products. And what we are talking about here is what I have already presented are the security assurance specifications, so the SCAS, in 3GPP a technical specification 33.x, which I've shown you earlier, and later I have an example summary of what it is currently adopted by the GSMA. This slide taken by the first document, so the roof of the house I presented earlier, presents high level the process, and it consists, as I said, 2 parts. So the first part is about the assessment of the security related to the development of the product and the product lifecycle processes. And the second is about the evaluation of the network equipment themselves by test laboratory. And here you may see the scheme. You have the different players and in the different roles. So you have the GSMA is here, 2GPP is here, the mobile operator is here. So that's the ultimate beneficiary of this work, also receiving the reports and in terms of evaluation and auditing of the process. And then you do have the equipment vendor that is a volunteer into going through this process in terms of auditing and in terms of tests and evaluations. Now, in this process, we are not delivering a certificate. That requires a certification authority, accredited part. That's going to come next. What we're having here is our report in terms of auditing and evaluating the network equipment that will be then adopted by the corresponding authorities. So where are we today? But before showing that, this is just an example of the technical specifications in use while evaluating the different equipment by the test laboratories. And that's the list currently in use by the scheme 1.0. And I've just opened up one of those technical specifications where you may see the level of details, how the radio access network, so the RAN, not as GNOB, but it is the radio access network, the base station, the 5G base station, it is practically assessed. So in order to verify that all the corresponding functionality, the standard demands are truly support and meet the 3GPP requirements. So it's very, very, very detailed. So like here, they look into detail, the RRC integrity, the user plane integrity, etc. So very, 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 very detailed process, and that would then output a report that basically allows the carrier, so the recipient of the product, having assurance that the particular product can be trusted, can be trusted. Then how to achieve a resilient network, it is the next level of the security which I'm presenting in the last part of this presentation. So where are we today? So we have already in place the NESAS 1.0, finalized last year in October, and the NESAS 1.0 supports the basic requirement coming from the European Commission, in particular the EU Cybersecurity Act, which defines 3 levels of assurance. We have the basic, we have a substantial and a high, and the corresponding evaluator. So basics can be, an evaluation can be performed by the vendor themselves. So it's self-assessed. Then substantial with third party, and then high means that the National Cybersecurity Certification Authority must be involved. So the target here is that the industry is now collaborating with the agency, NESA, European Commission, in order to adopt and adapt the NESAS process in order to achieve the or realize the certification scheme. And then later, the NESAS now is under discussion, and what is in the phase of agreement that there will be, the technical specification will be further expanded, and by the end of this year, the NESAS 2.0 should be able also to incorporate a penetration test, a cryptographic analysis, and software engineering, meaning having in place requirements and a methodology to analyze the quality of the software. So it is a scheme, as we speak, well received and broadly adopted by the carriers, as you have modern tech carriers demanding for having the equipment validated through these schemes in terms of auditing, but also in terms of network equipment assessment. You have ongoing discussion and collaboration with a number of security authorities. I just mentioned NISA in Europe, the BSO in Germany, and the ANSI in France. And then, okay, the process has been driven initially by Ericsson, and then coming along together, the vendor, Nokia, and Huawei, just to mention a few. And then looking at the auditors and the laboratory accreditation for those two processes, what we have is that the GSMA has already selected 2 laboratories for performing the auditing task. And then we have more than 10 laboratories now being accredited to release this report for evaluating the network equipment. And GSMA is very strict. This is something that the test laboratory has to comply. Basically, they need to be accredited by the IIEEE, which stands with the International Laboratory Accreditation Corporation, and it requires that the particular laboratory complies with the ISO 20025, and it is accredited. And in particular, it supports all the NESAS requirements. So the process, widely supported, already ongoing, and I will show you what Huawei, but also other organizations have already attained. Now, there are many questions we receive. Usually say, okay, yeah, we talk a lot about common criteria, and why don't we use just common criteria, or what's the difference between this scheme, the GSMA and TGP are proposing now compared to the common criteria? So as I said, the common criteria has been in place for many years already, and they are especially designed for achieving a level of certification within the IT industry. And it's a lengthy process. For example, for an evaluation assurance level 4, it may require from 1 year to 18 months. So imagine how much delay they would introduce to launch the new product. Yeah, it's really a lot of work. Some of the equipment must go through common criteria. others common criteria are not truly suitable. For example, for the base station and of 5G or the in general the mobile system. That's why we're thinking of the NSAS scheme, which is a much simpler process, really efficient and effective in its evaluation, and it usually lasts maximum 6 months. And when we look at the details of the evaluation of the process for making a product and the life cycle management of the product, we compare the two things. What we have is that in the one hand, we have that for the auditing process, the NESAS 1.0 is already better than common criteria. So you see here, comparing one by one the requirements coming from NESAS and what will be practically supported by the common criteria. On the other hand, when we look at the contents of equipment evaluation and tests, so the NSAS is not yet ready to look at the compliancy towards penetration tests, so-called SCAS, so the software engineering and then cryptographic algorithm implementation analysis, and for example, how the random number are generated or what kind of algorithm for encryption are supported. Not ready yet. So in this sense, the common criteria for the range of products they've been designed for are more advanced, and the target is now to complement the NESAS 1.0 so that by the end of this year, we have also those schemes supported by the NESAS for the 5G products or in general mobile communication systems. Right. So examples of certificate, just to say, yeah, but where are we today and what your organization has done? Yeah, just as a quick summary, we have that, for example, Huawei has already attained a number of those certificates. I think for this presentation, it is relevant that the 5G RAN and the 5G core have completed the first NSAS audit evaluation, and they're now subject to the SCAS test. So for the equipment evaluation should be ready both for core and RAN by the end of this year, for then a massive network rollout and compliance to the carriers that are demanding for having passed those tests. At the same time, we have other certificates attained, especially for the core network, which include common criteria, because as you know, the core network, it is largely virtualized. It's pretty much an IT system. Overall, Huawei has obtained more than 270 certifications. Now we go, without going into the details, yeah, there are certificates for security of products, but there are also certificates looking at the security management system, so intended to see how the organization implements and achieves information security. Information means data, yeah, that's what is information. Information equal data, yeah, data security, the quality management of system, and the supply chain, how the particular organization handles the supply chain, so before achieving the end product, and then a qualification on information and security. Okay, we are now going, I think, in the most interesting part. It is how we can really become resilient to any kind of threat, attack. That could be from external organization, but it is especially true for internal organizations. The owner, so the one that they have the hands-on, they are using the infrastructure, the one that they have access to data, because let me say that there are three categories of information or data. So there is data at rest that you put in, you store them, you archive them. Yeah, data that's at rest, stay there in some place, you put it there. Then there is data in transit that we send from A to B and then returning from B to A. So that's transit. And then we have data in use. So we do have very important method to mitigate threats, risks for data at rest and in transit, but it's very difficult to do anything for the data in use. That's why the owner of the equipment, the owner in the sense that the one that operates, that has access, it's that's the where we need to pay mostly attention to, because it is the data in use. The data in use are not very easy to protect. For example, like I'm now watching this scheme, and this screen, and if this screen contains any kind of secret information, it could be like a right management system that I cannot print, I cannot copy, I cannot do it, but I can take my, what is it here? I take my, sorry, this one, yeah. I take my phone, yeah, and then I take a picture, done. So this is data in use, I can do anything about it. So that the cybersecurity is deployed, maybe it's a long process, and also the people has to be selected properly, educated, in order to achieve a trustworthy system and a resilient network, but also it is important that the people behave and know how to behave within the organization. Said this, we can think of data at rest and data in transit now. That is the focus of this presentation, and look at the possible solution to security deployment. So let's look at this slide. How much time we have? Yeah, we still have some time. So looking at this slide, I've organized this slide in terms of the practical domain of the network. So we have the device of any kind, they're here. This is the device. Then you have the 5G radio access network, which is here. Then we have the 5G core, which is here, with clear interface, separation, everything, it's here. Then we have the transport network layer that will allow us the communication between these two domains. Good. Then we have the data network or external data network, including the internet, or an internet, or it could be even an enterprise network that we want to connect. Then we have the management system and the MAC. The MAC. So here also the MAC is a lot of confusion, where it's extremely simple. The mobile edge computing platform, it is seen by the 5G system as an application function, nothing else. You say, oh, the blurs here, there's all bullshit. The blurs, no blurs anybody here. Everybody, it's crystal clear what is his name, where it is, that's it to a similar to the Mac. It's just an application function. So if it wants to watch, access, the carrier network must go through a user print function, which is a function of the core network. That's it, full stop. From the system perspective, it's nothing else than an application function of the network. But there are threats. Yeah, there are many threats. I'll show you how to mitigate them. There are many threats. So looking at the threats, we have many threats in the radio access network, from fake base station. We have threats to the radio interface, denial of service of any kind. Then the MAC, I will show you more in detail. Yeah, there are threats, because one of the reasons is that the MAC will be brought physically close to the edge. Also edge in a confusion. Let me define the edge once forever. Edge is anything around the end user. So if I'm in the end user with my phone, that's my phone. The edge is what is coming next to me. So in this particular case would be the base station. Yeah, that's my edge of the network. The other edge will be attached to what it lives, what it connects to the core network. Now, looking at the MAC, the need of the MAC is that it has to perform many things. One of the things it has to perform is to reduce latency. So I cannot put far from the edge, because the speed of the light, if I want to stay, like, say, below 1 millisecond two ways, I cannot go beyond 150 kilometers. I cannot do that. So I'm usually 10%. So we also have an element of physical security, that if I have to place this server platform proxy and the corresponding applications, I would have external people accessing the area, and therefore we also have some problem. And then the core network, we all have the problem of the cloud in general, because it's a service-based oriented architecture, cloud native, and all the functions, which are functions. So we have the corresponding threats. And then, of course, we have external threats of external attacks that may come from all over the places. And then also we need to mitigate access to the network in terms of network management at any level, especially for slicing, where you are opening up your assets to multi-tenant that they can do anything and everything within the limits, but to compose the function, so they create definitely a threat to your infrastructure. Now, the conclusions we have achieved globally, globally means not only in the industry, but also the governments, regulators, and the application providers, that the cyber space, cybersecurity in general, it is an effort that that expands across all domain, and it is a duty of all of us to behave and put in place the right measures and mitigation in order to achieve trustworthy products in the one hand, on the other hand, resilient system and services. And this is particularly true for confidentiality and integrity of the information, but especially the availability, that when I need something has to be there, not down. And that means the role of different organizations could be positioned like I've put on this slide. So we do have the vendor, they do have strong responsibility, and vendor must output trustworthy product, and the compliancy with the NESAS goes into that direction. Actually, it is one of the one of the many that truly proves the trustworthiness of the network element in compliance with the 3GPP requirements. On top of it, even more importantly, we have the carrier, the operator. So they are the real responsible, all these guys, because the operator is the main responsible. They are the owner. They are the owner of the infrastructure. They are the owner of the services they provide, and they are responsible of the security deployment. Imagine that I am providing a radio access unit. So this is radio unit, active antennas. Yeah, this box here, this is the BBU. That's the core network, another box. That's the BBU, that's the MAC. It's just Huawei implementation. So the BBU is here. It's a multi-mode, it could be 2G, 3G, 4G, 5G, just software upgrade. That's the box. If I give this box, then this box supports any kind of functionality. So I say through the radio interface, encryption, integrity, authentication, authorization, algorithm for verifying and blocking the denial of service attack, anything. But if the carrier does not enable them, what is it? Is that to blame the vendor, or is that, yes? So it is essential to have the mechanism in place, but more important is the security deployment. That is all the processes and compliances, mechanisms, responsibilities, duties, to have that in place so that the system becomes resilient. Resilient means that detects and respond to any kind of attack. Yeah. Above this, we have the application themselves. So you may have a fantastic trustworthy product, resilient network, and then what you do, you start navigating, and you are mistaken in inputting your data, like here, pay, credit card to the wrong website. So basically what you do here is you go to a website, there's no certificate. So if it is no certificate, there's no digital signature, there's no encryption, between these 2 points. You put your data there, and basically, yeah, you have basically violated the basic security principles. So what we need to have in place over the top are also the mechanisms such as the possibility of being authenticated, the possibility of encrypting our traffic, and verifying that service is really available. Like if the certificate that is showing the website, is that valid? Or for how long is valid? So I have the application layer has the responsibility of providing secure services and meeting CIA requirements in terms of confidentiality, integrity, and availability of the services. And then we have the standard organization, which I've already discussed for 1 hour. They're responsible for many things, but equally responsible are the government and the regulators, that they output 2 types of, let me call, documents. One are the laws, and the other one are the regulations. The regulation applies to the industry, and the law applies to anybody. And yeah, and it's extremely important to have in place the right laws and the regulatory framework, so that we have mechanisms for defining clear requirements, but also methodologies in place, so that we are achieving a large degree of compliances, even targeting the safety. So from security to safety of a particular country. Now, said this, I mean, rushing through the a few deployment aspects, and what I'm presenting cannot be generalized. Yeah, this is something that comes from our organization, comes from Huawei. So how Huawei cope with and solve a certain problem. And what I'm presenting, it's not comprehensive, so it's not exhaustive. It's just an example to get a flavor of how certain things can be done, or how certain threats and risks can be mitigated by a security deployment. In particular, we will look at the 5G security deployment. First, this slide is already introducing pretty much all the elements. So as I said, that your system has to be aligned as to comply with the standard. Must have in place all the mechanisms I tried to introduce today. And here is just a summary of those, I guess, to support protection, integrity, and so forth. So standard compliancy is necessary. And the NESAS, the process I showed you earlier, it gives you a chance of having something compliant with those particular requirements coming from the GSMA and the GPP. But that's just the minor part. If you really want to achieve an intelligent, in-depth, end-to-end security solution, you need many more enhancements to that. And we are talking about equipment security. I will show you how we can make equipment secure. You need to have mechanisms, functionality to secure your subdomain, like how you secure your RAN system, your core network, how you make your Mac secure for all stakeholders, how you ensure that security is supported by your slices that cannot be compromised. And then how do you cope with the massive connectivity? Now we're talking about millions of connections per square kilometers. So user and control, how you do it? We need to have also proprietary solution. And then importantly, that's one of the first requirements I presented you. How do you handle all this complexity? So finally, it's not just about being certified. That's not the point. So certification, it is like the CA stamp of a product entering the union. You need to go towards a risk mitigation framework, risk mitigation framework, adaptive risk mitigation framework, and therefore you need to have the means and the methods in place that you are performing your task in a way that it is as autonomous or automated as possible. And here we are talking about how you will handle your equipment, so the equipment management system, but I think more importantly, how you look at the system end-to-end or your own security control zone in a very agile manner. And here we're talking about security operation centers. And I will show you later that will help you go through the identification, the protection, to the detection, how you intend to respond to certain attacks and threats, and then how you would recover if something happened to your end-to-end system. End-to-end system for you is your security control zone. Okay, quickly through equipment security. And what Huawei does for equipment security, the first thing is to achieve a separation of the three planes. So we're talking about the control plane, user plane, data plane. And the separation is not just logical here, it is physical. So our implementation, the equipment, like taking the run and the core here, has been done that we do separate this stacks. So each protocol stack, control plane, user plane, data plane, has its own corresponding logical IP address, but also physical port. It's separated. So it means that if you attack or you tamper one of the planes, the other one is not affected. In addition to this, we support encryption end-to-end. Different type of encryption is applied to the different type of traffic. For example, traffic towards the OSS, so management traffic, is encrypted using the transport layer security, TLS encryption. Then we have IPsec tunnels for carrying the control plane, similarly the user plane, which are separated. So separation of the three planes is essential. I would say separation now coming of the 4 planes, because we will have also the machine learning pipelines coming in parallel to that, that would require and demand for separation as well. So separation and isolation is the password we need to have for each network element. The other important thing, it is to achieve a trusted execution environment so that you have a secure device or network element operation. So you need to achieve this trusted execution environment. What it means that I need to have 100% control of what I'm doing on that particular equipment element where my hardware is located. And what Huawei does here, we have 3 basic steps, and all done at chip level. And it is at chip level that is burned the root key for the mother of the encryption. And therefore, we have the possibility of encrypting the data in that particular at rest, but also we have the possibility of exchanging certificates and digital signature in the software that we upload. So there is no way to mistake the source of code and its origin carried with a digital signature and the corresponding certificate. We do also have a possibility of having real-time and remote attestation of what happens within the execution environment, where we have the possibility of verifying the software, the firmware during the setup. So the system start up, and therefore we can immediately and prevent any kind of malicious action that could come to the software or hardware, or any kind of compromise. And finally, we provide a secure operation so that all the sensitive function will run and will be executed in a very well dedicated, isolated security control zone. Security control zone. I will show you what it means within the core network, just as an example. The other important thing is that we need to achieve in terms of equipment security is the intrusion detection system. So we need to have an intrusion detection system within our network. What is it about? Practically means the possibility of supporting native agents that allow you to analyze what happened within the network elements. Here you have example, the Huawei ISAC, which is an intrusion detection system that allows the support of a native agent within the node B, so within the radio access routers, and then in the transport network access network, OS as well, and then within the virtual network. So this is particularly true for the core network, the possibility of monitoring within a container virtual machine, what happened to the hypervisor on which your virtual machine ran and the corresponding container. That is making possible in practice to scrutinize, have transparency within your network element, within your security control zone, or what happened, and detect any kind of attack. So this is an example of our OS attack. The attack chain is practically supported, and also you have on this slide an example of container virtual machine attack chain detection into 4 steps, from discovering the vulnerability down to the escape container, the virtual machine, and so from and above, from investigation in exploit the exploitation of vulnerability and an understanding of whether anything has been implanted in terms of malicious codes, and then evidence detection, and then more action to be taken so that the corresponding problem can be mitigated and resolved. Now, looking at the security domain, we have different type of mechanisms in place to achieve security deployment. This is an example of the radio access network. Again, our algorithm and functionality supported by the Huawei, I believe other vendor should have those capability, and the operator must enable them in their network to make the network resilience. So the possibility of identifying whether it is being deployed rack-based station, we do have algorithms that analyze the end-over success rate. So if you have a lot of failures here you have a problem. It means that there is somebody that pretends being a base station to capture your traffic, can be detected easily. The other thing is the protection of the traffic that crosses the radio access network. In this case, we must enable and support all the PDCP. So that's the convergence protocol at the radio interface that you need to support the encryption as well as the integrity protection of the radio interface. In addition to this, our radio access system, it allows the encryption of the communication towards the core network and the corresponding management player, including the support of the carrier public key infrastructure framework, the certificate, so that we know and we validate and authorize the particular traffic or access to the network. The core network, it is a service-based architecture, so cloud-oriented native system, and it looks like here you have a network function virtualization infrastructure, a virtualized infrastructure platform on which you have different function in the network, from supporter slicing, repository function, policy control function, user data management, unified data management function. That's where the data are practically stored. And then you have encryption, etc. So that is basically subject to a number of threats. So the threats could come from outside, so from other network, including other visited public and mobile network, the internet, but especially coming, say, from the OS, the OS, improper access to the network, and from the radio interface. So how do we prevent and mitigate this kind of attacks. It's just an example of three solutions. So the first is to introduce the hardening models that expose high-risk attack surface. So that means we avoid that the traffic reaches out immediately the logic model. We need to prevent that we have an immediate access to the kernel, the most important part of your functionality. And we can introduce like an interface model as well as perform some tasks during the parsing and analyzing of the traffic, inbound traffic. The second action, it is equally important, is to provide isolation. Isolation, and it's usually hierarchical depending on the level of security you want to have in your network domain. For OEM zone to a trusted zone, here you have an example, to the service domain, therefore to the trust zone of your core network. In this particular case, you may introduce a firewall, even virtual firewall, as well as that you perform an access control and the gating, so that each compartment of your core is basically isolated from the other part of the core that you consider more important to be secure. And then, of course, the element has to support the diversity and the possibility of distributing this function in a number of cloud platforms. In this case, you would introduce diversity of the function, that if something goes wrong in one part of the system, so that particular access modality function has a problem, it has been basically put together, working together with another function. So this particular function can be relocated and another function can take over what is practically no longer working in the other equivalent function of the network. So we need to introduce diversity at the logical level, so multiple logical functions performing the same task, as well as possibly use also different physical elements. And you need to have the software that orchestrates and makes that possible, that one thing goes down, availability is still in place because something else is coming up. Yeah, and has to be supported and enabled by the operator. Now, the mobile edge computing platform, as introduced later, it's a very hot topic. And yeah, there are a few threats that can be mitigated. Practically two possible deployments. So how do I use this box, which is a box? Yeah, I presented the Huawei design earlier. How am I using it? The problem is that this box has to be going very close to the other elements of the access system. So if we think of a scenario with carrier aggregation, in a carrier aggregation room where you may find more than 100 base stations, we do have some problem. We have a problem with location, because when the people will access this part of the network, we also have the possibility of seeing and touching other equipment you don't want this particular organization to see. So that's a problem. It's called physical security. So you need to think how to mitigate that, and it is practically possible. The other problem is coming with different interfaces. So remember, anytime we want to go towards ORAN, Open RAN, we want to open everything. The more you open, the more interface you create, the possible threats rise exponentially. Yeah. If in the one hand, you may think of diversifying the supply chain with more vendors, which I doubt it, because the ultimate buyer would need deal with so many people you don't want to do this. On the other hand, you introduce one interface. So like the Mac, it's coming along with three main interfaces. Let's look into this interface. So this box basically hosts application functions that could come from third party. It has to work and connect to the user plane function of the operator. Yes, because it's an application function of the 5G system, nothing else. And you have that the enterprise network has to communicate through the carrier network. So there's an exposure possibility of having an access from the carrier network down to the enterprise network that we don't want. So those are examples of problems we may have by introducing the mobile edge computing platform. It can be mitigated. So the two basic threats I introduced earlier, it can be mitigated if we always need to perform an access control. When you do an access control, you mean you need to authenticate. You must authenticate. Anything that comes to you, you need to authenticate it. So that's the first thing. There are mechanisms to do that. Once you introduce the authentication, you need to think of authorizations. Okay, that's you, yes, but you are only able to do A, B, C, and that not D, you cannot do it. So you need to authorize it. And then you need to have accountability. Accountability means that if something happened, I need to be able to trace everything in place that I can reconstruct, identify the root cause of any problem. Yeah, that can be done, can be put in place. And in the particular the Mac, we are thinking of introducing firewalls and mechanisms I present you for slicing, so that the confidentiality, integrity, and availability of the corresponding information, the free players, that could be the one I mentioned here, the application provider, the Mac platform provider, that could be or cannot be an operator, and then you have the enterprise system. This is an example that explains how to protect the Mac platform from third-party applications. And you have concern coming from the carriers, because you have application now coming close to your core network. You are basically touching upon the user print function of the carrier. And then you have the third-party concerns, because the third party basically comes along with application, but also with data. They could expose interfaces to something that could come along the carrier network. And here you have example how these particular threats could be mitigated. Slicing. Net slicing comes already in release 15. It is a function especially enabled by the core network. It is the 5G. Okay, there are tricks to slice the network, even a 4G system, but that's not the point. So the real slicing comes with the introduction of the 5G core, and slicing is about a composition of network function or network slice instances end to end. So that means chaining, binding function of the core network, and then create awareness in the radio access network through proprietary algorithm. And then you need to make the terminals aware, slices aware. And now the terminal can support up to 8 different slices, so that each terminal maybe then camp and use services of the corresponding slice once it is authenticated and authorized to use that particular slice. So practically, we may see that as a virtual network end-to-end, designed for composed, put together for achieving and serving a particular usage scenario. In this particular case, we are talking, for example, of slides for enhanced mobile broadband traffic, another slide for massive machine type communication, and then another one for ultra reliable related communication services. Practically, I have virtual networks end-to-end, making use of the same physical infrastructure. Therefore, it is a multi-tenant problem where you do have a network slice template, which is pretty much using a web type of interface that a third party can compose its network based on service level agreement. Say, okay, I want to connect cars, I want to connect robots. I don't need to buy the infrastructure. I just subscribe to a carrier that exposes those capability in its own marketplace through a web interface. Start composing and then I do, yes, these are the SLA, this is what I want, including performance in terms of latency, relativity, and I say, okay, yeah, purchase it, and then you buy it, and then the service, it is embedded, the different function embedded, enforced, And then the control plane establishes those particular communication through a number of instances across the whole network. So there are many problems here. If you think in practice, you have a multi-exposure to tenant. So you have a management interface you need to think of to make that secure. You have problems of having an end user attempting to access more slices. I would like to pay, for example, only for an eMBB slice, but also enjoy the traffic of ultra reliable low latency when I feel convenient to do that. Like my son puts on the VR AR glasses without paying it. Yeah, that's a problem. Or may have denial of service attacks on one slice that could practically affect other slices. So what can I do that to mitigate all those possible or potential threats, risks for my infrastructure? Yeah, if you look at the 3GPP release 16, and then later, of course, the 17, they came along with very interesting mechanisms to mitigate the threats I mentioned earlier. And here, there's just examples of how we can achieve this, what can be supported in practice. Yeah, let's go from quickly, very easy. So you have the multi-tenant, they want to compose their slice. So what you need to do, first of all, you need to authenticate them and authorize them. And that's done now. It can be standardized using the OAuth mechanism. And then you need to encrypt the communication between peers. Now, I know who you are. Yeah, let us encrypt our communication. The didn't transfer cannot be compromised by another player. Then, easy, you may introduce the digital signatures using the X59 certificates, which is what your Chrome nicely supports, that proves that the validity of that particular web interface. It provides you the public key, and you may use it for encrypting your traffic, but in addition, it provides digital signals, so you are sure that you are really accessing to what you're supposed to do. Then we have the problem of the slice utilization end-to-end. And here we have two main things to consider. First is that you are accessing a specific network slice, and only the slice you are authorized for. And the second, you need to have in place a secondary authentication for accessing the enterprise network, which is beyond the virtual pipe you are creating in your slide. And this is possible because it is introduced the functionality, the NSSAA that comes, you may see here on the screen, with authentication and key management in 3GPP release 16 that is basically supported by the system. In addition to this, we may encrypt the NSSAI. It's pretty much the identity of this slice, network slice, selection, assistance, information. So it's pretty much the stamp that's scaling along the network for setting up and the slice, maintaining it, and releasing it. That's encrypted. And then we may introduce a firewall for protection and encryption once we are leaving the public land mobile network. And finally, what is advisable to do, and you would need to demand for your vendor to support, is the possibility of running your different logical networks, your slices, possibly into separate network equipment, including isolation in the transport network layer. This is an example that we achieved with the Flex E, that is a function supported by the transport network layer equipment or Huawei that discriminated different traffic. So you have isolation between the slices achieved through the mapping. Similar things, you may think of having a zone and isolation for your virtual machine, that a particular communication service may be in one place, and like ultra reliability communication could be in one place, another. You may think of enhanced mobile broadband services. The other problem is around the massive connectivity, and this is what we're expecting for 5G. So 5G is connecting, the target is million of devices per square kilometers, and therefore there will be attempts of a number of improper access, stress with both the user plane and the core to plane. How do you mitigate that? You need to measure. There's not a better system than the measuring. So the suggestion is to have native agents, so native capability of in the equipment you buy that would allow you to scrutinize, discriminate, see transparent what happened in your network element and trigger the corresponding action, possibly also demand for algorithm that certain connection could be released and or diverted or offloaded depending on what you measure. Yeah, to conclude this presentation, I have a very last slide, which is meeting the second requirement I presented earlier, being the third, the security assurance, on the management. So like having a security operations center that allow you a fast detection, response, and recovery according to the NIST CSF best practice. So coming from the US framework targeting the network resiliency. And what you need to have, the network, how do you achieve this? So first, you need to have in place trustworthy equipment, complying with the common criteria, NESAS, and any other best practice and assurance scheme you think of. Yeah, that's the first thing. Second, you have to think of achieving resiliency from external attack, but more importantly, from internal attacks. That's the problem. Remember, the data in use, it's very hard to protect, yeah? But we need to target, yes, that one, but especially the data at rest and in transit. That could be achieved by thinking of having in place native agents that transparently can show you what happened into your network in terms of configuration, software upgrades, traffic, pico traffic, denial services, installation of malicious software, anything, that's thing. At the same time, you need to have the capability of measuring and analyzing it, possibly with a large degree of automation, because we can't watch everything. So that artificial intelligence could be in place for pattern recognition and helping the analysis of the data and trigger the corresponding action, which means security control. Security control actions that could be of various types. And what the carriers are doing in practice is to provision new security policy once the possible threats are discovered through the assurance mechanism that put in place into the network. In addition to this, of course, we need to have a configuration management in place that makes it possible for the network operator or administrator in general to configure the parameters, especially the keys and the certificates, identities, anything that has to be set, put in place in alignment with organization, policy, strategy, and processes and procedure to achieve an end-to-end resilient system. So that basically concludes my presentation. And Sandy, what do you think? We could have still room for some questions.
Thank you very much, David, for a fantastic presentation. You've given us a comprehensive coverage of many aspects of 5G. What I asked everyone if they've got any questions to type them into the group chat on Zoom. So there are about 5 questions there so far, and possibly more later, but probably we can start off with, David, do you mind taking some questions now? Or are you tired? Or
no, it's good. Yeah, I'm fine.
Oh, good.
Yeah.
Okay. The first question is from Ashan. He says, with regards to end-to-end encryption, how are telcos meant to comply with government mandates where backdoors are to be granted to customer devices while complying with 3GPP security standards? That's the question.
Yeah, I think we are mixing many. The question is very complex because I think it brings many aspects, say from in general cryptography, which is about encryption and integrity, down to discovering of vulnerability, which is about, for example, it is software engineering. So it's completely different problems and the solution to problems. Coming to the encryption, so coming to the confidentiality and the integrity, if we look at, let's go back to the, sorry, I need an architecture. Sorry, yeah, it's a bit slow. Yeah, I could use any. Anyway, so what we have here in place is that the 3GPP has nicely well-defined all the mechanisms now to achieve an end-to-end encryption by using different mechanisms at different interfaces, so that the traffic crossing that network from peer A, being peer A user equipment, down to a peer B, which is another user equipment as defined by the standard, you do have encryption and you do have integrity protection. Like this signaling, it is encrypted, end-to-end, being the terminal and down through the core network up to here. Then when you're leaving this, you have to encrypt at this interface. That's also supported. And then the user plane, it is support in terms of encryption, integrity, the radio interface, and then you need to have in place the security gateway, so that brings along your encryption across for user plane, control plane, and management plane, so that all your system guarantees the confidentiality and the integrity of the information. Yeah, availability means also diversity in the supply chain. So that could be achieved by diversifying your supply chain into the redundancy and so forth. The question around vulnerability is a completely different story. It could be a vulnerability defined by a misconduct, like say, oh, sorry, I've forgotten, apologies, I've forgotten to encrypt your communication from A to B, or sorry, we forgotten to activate the encryption of the end user data within the UDM platform. Yeah, it is something that it is a vulnerability because of the function is either not supported because of cost saving. Usually cybersecurity is always left at the end. So, okay, wait a minute, let me offer this service. Then when my return on investment is okay, I mean, think of encrypting this, yeah? Yeah, that's a problem. Or it could be like, there's a problem in the procedure, in the process. Or it could be something like, they're thinking of this something implanted into the system that could be started by either an internal player or an external player. How to mitigate that? I think it is also very possible. And in this case, means to introduce I mean, you need to have always authentication, authorization, and accountability at any interface. If this is in place, there is no way of activating anything which is outside the scope of the legal operation or the organization or through a certified process. On the other hand, there is nothing possible to leave the network, the traffic, to be penetrated by the network, if I can simply analyze anything in detail that abandon or it is an outgoing traffic from like an open door, which I could enter from outside. We can scan all possible door and anything that can be identified. If the vulnerability is found, may or may not be a big problem. The vulnerability is a problem if it is exploited and not fixed once discovered. Because if it is discovered, could be exploited more rapidly. So it has to be found, fixed immediately, and fixing it is the responsibility of who provides the particular equipment, and is also responsibility to immediately upgrade the software by the service provider, so that I mean, may happen, anything can happen, especially say if you look at the software web type of application, your browser, there are many things that could be found within the browser that could embed other software and allow people to either steal your data or penetrate within your security control zone. I'm not sure whether yeah, because the question is very complex, but I appreciate that we understand the differences between what has been asked. Yeah. Okay, good, David. Probably you can just, for the next two questions, you can just give very brief answers because we are running out of time. The next question is from John. He says, so far LTE, including 3G, was using FDD, but for 5G, for example, 3.5 gigahertz band, mostly will use TDD. Why was there such a move? Oh yeah, that's it's simple reciprocity of the channel estimate. Yeah, this if you looking at the MIMO, yeah, let me go back. Sorry, it's not easy to handle the slides, but yeah, if you go to the spectrum, just a bit rapid. So it's because of the channel reciprocity that the massive MIMO, while being simple, while orienting, so while defining the beam towards the end user, needs to resolve our formulation. In order to resolve the formulation, needs to know the channel. Yes, if the channel is reciprocity, I could measure the channel in one way, use also in the other way for making my, it's just because of the channel. Now the technology is improving, and you may see also the possibility of deploying massive MIMO into the FDD. So that means when you need to estimate the channel in both directions, which is much more inefficient. So the reason is because of, main reason is because of the reciprocity of the channel. Let me see if I find the spectrum I presented at the beginning. Okay, that's fine. I think that's a good answer. That's basically, yeah. Probably the third question is from Terence Smith, and he wants to know, are you able to comment on 5G system power consumption, including base station, compared to 3G and 4G? Yeah, I'm sorry, I didn't go into this detail, but yeah, the power consumption has been reduced dramatically, and there are two main reasons. The first reason is that the technology is basically improved in its design. And if you look at even the transmission, we tend to avoid the many conversion from electrical to optical and so forth. So then the interfaces coming with the new radio have been further optimized and designed that you are on air. So you are consuming energy, so you transmit, you radiate only when it's extremely needed. So there are mechanisms implemented. So we have improved the protocols, so the way we communicate, how we communicate, the technology in order to perform certain tasks, but we also have dramatically reduced the size and the way we access to the equipment through automation, and that basically using AI and analyzing also how those functions perform. We can further improve, reduce, and shut down certain functions in the network that they perform only non-functional tasks not needed in a particular moment. So you can put it down and then only let the communication going through where the traffic is. So yeah, that's basically in high level. And the 5G has, I think, a massive improvement. Perhaps we could organize another talk where we can go through the implementation, and here we can understand more of what I'm talking about.
Okay, good. Okay. Probably, I think because of time factor and the fact that we've passed our time limit, we will stop here for today. And I will try to pass the other remaining questions to you by email, David. And then
thank you.
We will stop here for today. And thank you very much again, David, for your fantastic presentation. And I think everyone would, has mentioned on the chat that they've enjoyed listening to your presentation and the of detail it has gone into. So yes, so thanks once again. And so we'll stop here for today. And thank you everybody for joining us as well.
Thank you so much for hosting me, and goodbye.
Okay.
Ciao, ciao.
Okay, thank you. Bye.
Ciao.